Static and sliding friction. In this module, you will learn about static and sliding friction. For this simple activity, we shall make use of a box, a spring balance, string and a brick. Now, let us begin our activity. Tie a string around the box. Pull the string gently. The box does not move. We have to apply a force that is sufficient to overcome the friction. Let us measure the required force. Attach the spring balance like this and pull the box. When the forces are small, the box does not move. Increase the force gradually and note the force when the box just moves. The spring balance shows the reading of 260 grams. Now, the box has started moving. Will the force remain the same even after the box starts moving? Carefully observe. The spring balance shows a less force. Now it is showing 160 grams. This means that only a less force is required to maintain the motion than to initiate the motion. Initially, we note that there is no friction between the two surfaces. When an object is pulled and set in motion, friction comes into play in order to hold the object at rest. When we apply more force, more friction develops. This friction, which acts between two surfaces at rest, is called static friction. However, it has a limit. The limit is called the maximum limit of static friction. It is equal to the applied force when the object is about to move. When one object slides over the other, the frictional force acting between the objects is called sliding friction. In order to maintain the motion at a steady speed, we have to overcome the sliding friction. Here, after the box began the motion, the spring balance showed less force. This means that sliding friction is less than the friction needed to begin the motion, and so we have to apply only a less force to maintain the motion. Therefore, we can say that the sliding friction is less than the maximum limit of static friction. In this module, you've learnt sliding friction is less than the maximum limit of static friction.